Welcome to Easy Math TV. We're going to continue our discussion of statistics, and in this case, we're going to continue exploring different types of inference of when we're trying to estimate a population parameter based on a sample, and we're actually moving from just a single sample estimation to two sample estimations. So this is going to be, the topic here is on two proportions. So basically confidence interval of the difference between two proportions. So, because usually you're asking some kind of a question about like whether two proportions are different or not. So we're going to be building a confidence interval on the difference between two proportions using this claim that's given here. So we actually have some data to look at. And also just keep in mind too that this video is going to be split into two videos because it just takes a while to get all these formulas into your spreadsheet. So this is part one of two videos on the confidence interval of the difference of two proportions. Okay, so this first part of the video, we're just going to get all of these formulas set up that you see here between columns B, C, D, and E. If you already know how to do that, then you'll want to move on to video 2. Okay, so let's just read the claim so that we have kind of an idea of what we're looking at here. Our claim is that the proportion of men who use tobacco is not the same as the proportion of women who use tobacco in a certain year, in 2024. So usually in a situation like this, we're talking about categorical data. So the data is, do you use tobacco? And they probably answered yes or no. So we have like yes and no is a categorical value. So we're looking at the proportion or the percentage of people who said yes. And we're claiming that there's a difference between men and women. All right. So that's why we have two samples that we're dealing with here. Sample 1 is going to be, we're splitting up our data. So we had a sample of 980 adults. That's what the information tells us. We had 980 adults that were randomly sampled. A portion of them identified as women and a portion of them identified as men. So we're going to separate the data into those two groups, and we're going to see if there is, in fact, a statistically significant difference between the two proportions. So in the first several rows here, I have everything highlighted in gold because the gold color are numbers that we are going to provide based on whatever problem we're being asked to solve. So if you're going to be using this spreadsheet as a template for solving any problem involving a confidence interval of the difference between two proportions, okay, only the things in gold are the things that you're going to want to change. Everything else that you see in blue is going to just get calculated automatically. That's the nice thing about being able to use a spreadsheet over and over again as a template for yourself, because then all you need to do for future problems is to update these numbers that are in gold color here. All right. Now, some of these are actually calculations, but from one problem to the next, you might be given different things. So the calculations may actually differ from one example to the next. All right. So first thing we're going to do is just get our numbers in. So basically we have 980 adults and 420 of them were women. So that's the first number that I typed in. It's in cell C4 here because that's our sample size of women, and that's 420. So I literally just typed in the 420. Then it says that the rest were men. So over here in cell E4, I want you to see that I just typed equals, and because I just used Excel as a calculator at that point. So I just typed equals and I typed 980 minus 420, just to get the number of men in the sample. Okay, so together you have 420 and 560. That should add up to our 980. Next are our p hats, because it says 10% of women in the sample use tobacco. So that 10% is what we call a p hat, and that is a sample proportion, and that number was typed into cell C5. You can change the format of that. I have it formatted as a decimal, but if you go up here in the format menu bar, we can change that to a percent if you'd like. So you can actually look at the drop-down menu here and just change that decimal to a percentage if you want. And now you can see what that looks like as a percent. Same thing is true for the p hat for the men. It says 15% of our sample, 15% of the men who were sampled use tobacco. So that's 15% over here in cell E5. So again, if we wanted to display that as a percent, we could. The last two things we needed to calculate then were the two X's. So our number of successes, which is basically the number of women who actually reported that they used tobacco, was 42. And that's just equal to 0.1 times 420. So 10% times your 420 gives you the number of women that reported that they used tobacco. So the number is X, the percent is 10%. Over here in cell E3 then, that's just equals 0.15 times 560, because I just took the percentage and multiplied by 560. And I just used Excel as a calculator, and I didn't use cell references there because for future reference, like you may need to calculate different things, as I said. Like, so these typically are going to be values that you will be given in the problem. Some of them you will be given, and the other ones you need to calculate based on the ones that you know. Okay, so that's why I've colored them in gold, and I have not used cell references for them, because those are kind of numbers that we provide from the problem. Let's just continue down this column and fill in the remaining values that we need. The next number we need is to calculate 1 minus p hat for both the men and women. So let's just read across here. This is in row 6. So 1 minus p hat is just equals 1 minus p, the number in C5. So in cell C6, we have equals 1 minus C5. Hit enter. And then in cell E6, that's equals 1 minus E5. And again, those are using cell references because those are going to be calculations that we can depend on going forward. Anytime we put in our p hat, the 1 minus p hat will get automatically calculated. In these 4 cells, so in rows 7 and 8, these are our test thresholds. And we're going to calculate those because sometimes homework problems will ask you, does my data support using a confidence interval? Do I meet the success threshold, and do I meet the failure threshold? So the success threshold is in row 7. The failure threshold is in row 8. So let's look at those threshold calculations. So in cell C7, we're going to type equals C5 times C4 and hit enter. And then in cell C8, you're going to type equals C6 times C4 and hit enter. Over here in column E, in cell E7, you're going to type equals E5 times E4 and hit enter. Notice that's the same as X. And then in cell E8, equals E6 times E4. And that's our failure threshold. In other words, that's the number of people who identify male. So if you're a man and you do not use tobacco. So men who use tobacco and men who do not use tobacco needs to be at least 10, more than 10. And then the women who use tobacco and the women who do not use tobacco, each of those categories needs to be at more than 10 as well. So we have met the threshold that we need. So we're good to go. Now in cell C9, I just have typed my confidence level there, and that was given in the problem. It said create a 98% confidence interval. So my confidence level is 98%, and that's typed into cell C9. Right below that, I also have my significance level, alpha, which is equals 1 minus C9. So again, that's a formula that is based on the number that we typed into cell C9, and that's going into cell C10, equals 1 minus C9. Notice that if you add those two percentages, the confidence level plus your significance level, that should equal 100%. Just as we did in previous situations where we were doing confidence levels or even hypothesis testing on a proportion, we need our cumulative probability, and that's just going to go into cell C11 here. So inside cell C11, you're going to type equals and 1 minus, parenthesis, C10 divided by 2, close parenthesis. So that's your alpha divided by 2, by the way. So again, equals 1 minus, parenthesis, C10 divided by 2, close parenthesis, which is basically 100% minus our alpha divided by 2%. The cumulative probability is the area of the left tail plus your confidence level percent. So it's slightly larger than our confidence level. And lastly, we need our z value. So this is, we refer to this as our z subscript alpha divided by 2. So that you'll see it labeled that in textbooks. But this is the z-score that we need as part of our calculation for our margin of error. So this is going into cell C12 now, column C, row 12, and that's equals norm.s.inv. So equals norm.s.inv, parentheses C11. We need our cumulative probability inside the parentheses there, and we're getting the standard normal z-score, which is basically the inverse of the standard normal function in Excel. So if you typed in everything correctly, our z-value should be 2.3263. With more or less, you can have more or less decimal places, but that's the value. Now let's go over here and finish column E. We already had our 1 minus p hat. That was in cell E6. Again, so in cell E6 we had equals 1 minus E5. And we already calculated our two thresholds, our success threshold and our failure threshold. So now we're going to calculate two types of standard errors, okay? The The type of standard error that we're going to use for this particular problem, and that you will see me refer to in part 2, is the standard error of a confidence interval. Okay, so let's just look at that formula, and then I'm going to end this video and then take it up in part 2. So we're going to end part 1 here with our standard error calculation for a confidence interval. And that's in cell E9 here. So equals SQRT. So SQRT again is a square root, because standard error is similar to a standard deviation. So anytime you're calculating standard error, you're going to be taking the square root of something. So it's equals SQRT parenthesis. And what we need is our variance from each sample that you see here. So there's going to be two things that are added. The first thing is C5 times C6 divided by C4. This is all inside the parentheses of the square root. So C5 times C6 divided by C4 plus E5 times E6 divided by E4, and then close parenthesis. So let me just read that whole thing from left to right. Equals SQRT, parenthesis, C5 times C6 divided by C4 plus E5 times E6 divided by E4, and then close parenthesis. So if you did that right, and you're using the same numbers that I've been using, your standard error for the confidence interval should be 0.021-02295 plus or minus some decimal values. Depending on how many decimal places your value goes out to, it's going to be that number. All right, so I'm going to stop there. I'll see you in part 2. Like, subscribe, comment down below, and I'll see you in part 2.